This module covers user profiles. User profiles are user-specific pieces of the data within the Windows operating system. So, for example, if I have a desktop, it is my desktop, and another user logged on the same computer, doesn't matter if it's the same moment or in different moment, probably has his own desktop, and it is pretty obvious. How profiles work internally? Within C users, this is the default location, users, we have a bunch of folders. Why it is C user and what is going on inside? We can see it in the registry. Regedit, and within Regedit, of course, as admin, you can see the key name profile list under Microsoft Windows NT current version. Of course, it is a computer part of the registry, not the user individual one. Here you can see list of seeds, and there is information about profile. So, for example, for a user I'm being logged on, you can verify with whoami/all. I can clearly see that this is my seed, this is this seed being repeated here as well in the binary form, and I have information. My profile image path is EC users GT. There is some other information about the profile, for example, load and unload time. I will show you later how interpret those values. There is information that it is a full profile or the partial profile. There are some flags, like if it's an admin, if it's a guest profile, if it's temporary profile, it's a mandatory profile. So every single bit has a meaning, and every single user logged on this computer when a new profile is created for such user, an entry appears here. So from the forensic perspective, listing profile list content makes a lot of sense. Under profile list, within the root set of values, you can see some information about how profiles are working, and you can see there's information where profiles are going when new profiles are created. When new user logs on, user that did not log on previously, the default profile, this one is being copied for the new user, and the new user obtains this a copy of this profile as his new fresh empty, we would say, profile, even if it's not like totally empty, because even empty desktop is a desktop, contains desktop ini and some other stuff, not to mention the registry, etc. And if we dig into the set of profiles here on the drive, we can see the list of users logged on. We can judge by the date about the daytime and of logging and unloading the profile, which means logging off by the user, but we can also verify it in the registry. So to understand date and time for every single user here, we can use PowerShell, because it is something we'll mention a lot of times in other modules as well. It is about storing a time within Windows. I will refer to this user profile module every single time I will mention it, because I will explain it here. Because here it comes a bit more complex, because time internally within Windows is a 64-bit number counting an number of intervals, where interval is 100 nanoseconds, starting from January 1st, 1601. It is 1601 because is the closest reasonable date being divisible by 400 years, as calendar reoccurs every 400 years, specifying the first date in the before the moment Windows was written, and being divisible by 400 because it is reasonable, they picked up 1601, which is quite a long time ago. So here you can see those numbers are reg.w word, as word is 16 bits, double word is 32 bits, and high plus low, bits from high plus bits from low, can be converted into the 64-bit number. We can just stick those two hexadecimal values together to obtain one big number, but I will show you the calculation and how it can be done with PowerShell. The ultimate goal is to obtain the 64-bit number, and I will take if we take, let's take this one. This is not about me, it's about some other profile. I'm curious what time it was loaded. So I will pick this value, and I will specify my high equals 0x to specify is hexadecimal, and like this. And my low equals 0x, and I will pick the time low value, Control C, and like this. Now I have two 32-bit numbers, and one represents the first part of the 64-bit number, the high one, and the low, less important part of the 64-bit number. So to calculate the total value, let's call it tot equals, I will cast this high as long value, long, and I will put high, dollar high, oh come on, dollar high, and I will shift left by 32-bit. By 32 to have like bits from 0 to maybe not from 0. Give me a second. Notepad. I have like 64-bit number. Let's play it with 8 digits. So I have a high being here, and I have a low one represented here, but those are a bit longer. So I have shift left the high and then add the low part. So I'm shifting left the high part plus dollar low, and I have some huge number, it is 64-bit number, responsible for the total number of ticks. And I simply cast it at the date time, dollar tot, and I will clearly see what is the real date and time stored within the registry. I messed something because, or they messed something because this number looks weird for me, while the rest is reasonable. I'm curious why it is like this. Maybe someday I will figure it out. I would blame Microsoft, not my calculation, but I may be wrong as well here. Anyway, this is the way how you can convert it. I'm really curious what is going on. Maybe they are starting the calculation from some different number. I will try to figure it out. I can promise it. And for sure, if I figure it out, I will write it on my Twitter profile. When it comes to the date and time, there is one thing which is quite important here, because everything internally within Windows is stored as UTC time. So if you are not in the UTC time zone, you must shift by the proper number of hours, right or up or down, to have a UTC daytime. If you are not sure, use like daytime calculator online, or just switch your date and time to the UTC, and you will have a chance to compare it somehow to the real values being stored internally within system. Okay, I haven't had a chance to figure it out. It is because daytime itself internally as a .NET daytime class, .NET counts the time slightly different way, because it starts counting. I'm using this one. So it starts counting from January 001. So it is why it is converted wrong way. So this number is absolutely correct, but this casting is wrong because of .NET. If I copy this number, I can convert it by adding 1060 years, or I can also simply place it within the converter here, so Control V, convert, and after converting you will see this date being properly formatted, because this date is the date of within the initial internal format counting from 6001, and daytime is counting from year 1. So that's makes the actual difference.